Okay, so you have your reference sheet, right, so that we can look at this, because we're going to need it. And we're going to simplify trig expressions. So remember, on your reference chart, those are identities, and they're all equations, which means they all have equal signs. These are trigonometric expressions. They do not have equal signs. There's nothing to solve for, therefore we're not solving, we are simplifying. Okay? So, when you simplify a trigonometric expression, that means we're going to rewrite it as either a numerical expression or in terms of a single trigonometric function. So in the end, you're not going to have an answer like sine x plus 1. It'll be like sine of x, or cosine of theta, or 1, or 0, or cosine squared theta, or 2 cosine squared theta. But there's just one term that you get. Okay, that's how you know you're done. And there are strategies for this, things that you're going to have to think through. You are going to have to actually use your brain cells and think and reason and figure out what's the best thing to do. You may go down the wrong road sometimes. You may go down a different road than your neighbor, and you both got the same answer, but one of you took a little longer. That's okay. All right? So your strategies that you want to think about, so we're going to do this first one, secant theta minus sine theta times tangent theta. So the things you want to think through are, I could rewrite it using reciprocal and quotient identities. I feel like that we could actually do something there with that. Look for Pythagorean identities. The Pythagorean identities will always have a squared something. There's nothing squared there, so I'm thinking I'm not going to have that, at least not at the beginning. Combine fractions using a common denominator. There's no fractions yet. Break fractions apart. Now that's the one that I feel like it'll make sense to you, but it's not always going to be the first thing that jumps in your mind because you spend so much time putting fractions together that you rarely actually break them apart. But that is the skill you need to be able to do to simplify these, okay? Or use factoring. So I would want to first just look and see, oh, is there anything I can factor out, like a GCF or whatever? There's not. So of all of those, I feel like the only strategy that's going to work at the beginning anyway is to rewrite it using reciprocal and quotient identities. And when you do that, you want to try and, you're kind of trying to get it into all of the same, not necessarily all just one trig function at a time, but most of the time you're trying to aim for sine and cosine. It's like the easiest way to go about things. So secant is the reciprocal of what? Cosine. So I'm going to make this 1 over cosine theta. Minus, then I have sine theta, and then I know that tangent theta, what's the quotient identity for tangent theta? Sine over cosine. This is sine theta over cosine theta. Okay. So everything's in terms of sine and cosine, which isn't going to happen every time, but that was an easy thing to do here. And notice I have equals because this right here, as crazy as it looks, is equal to this right here. And then what I'm going to write here will look different than this, but it will still be equal to it. All right, so when I multiply this, it's like sine over 1 times this. This is really just one big fraction that I'm multiplying together, right? That's how you multiply fractions. It makes it easy. So I have two fractions that have the same denominator, so I'm going to combine them. The denominator is cosine theta. The numerator is going to be 1 minus, well, sine times sine is sine squared theta. Right. So I have sine squared theta. Does that fit into one of the Pythagorean identities? It does. It's the one that says, so we look on here, right? Here's your Pythagorean identities. It's right here, sine squared plus cosine squared. Oh, I don't know if I'll be able to, oh no. Oh no, I can't click on my thing again. There we go. It is cosine squared theta plus sine squared theta equals 1. Now, I could solve that for sine and then substitute something in, but I can see that if I subtract sine from both sides, I will have cosine squared theta equals 1 minus sine squared theta. And you'll get to a point, and you may already be there, although I do think it's a good idea for you to write this on your notes so you remember where it came from, where you can look at this and see that, all right, if I subtract sine squared from both sides, then this is what I'll get, right? So right here where I have 1 minus cosine squared, where I have 1 minus sine squared, I can replace that with cosine squared. So I'm going to get cosine squared theta in the numerator over cosine theta. Everybody okay with where everything came from? All right, can I reduce this? Yes, I can cancel this cosine with one of these, and that gives me just cosine theta. I'm down to one term. I'm good. Okay. What questions do you have? Okay. So let's look at number 2. Okay. So for number 2, don't have any fractions yet. There's nothing squared. Really, I think the only thing that's going to be something I can actually do to it to get the ball rolling is to do the same type of thing I did here, and I'm going to change my tangent to its quotient. So this will give me sine of A plus cosine A times, and then what is tangent again? Sine over cosine. Do you see anything I can reduce? Yes. I can cancel out those cosines. So this leaves me with sine of A plus the sine of A. And what's the sine of A plus the sine of A? 2 sine A. Okay. What questions do you have? Anything? Just like anything else, this will get smoother the more you do them. You'll kind of understand the thought processes behind them and whatnot. All right, so on number 3, I do have the reciprocal functions. Now, I could change them to their reciprocals and quotients, but I don't know if that would be the best thing to do here. Could I factor this? I could factor it, right? It's a, what kind of situation is it? Cotangent squared minus cosecant squared. What is that? It's a difference of squares. That's all it is. You got to recognize it whatever situation you're in. But factoring it like that right here isn't necessarily going to help me. I'd rather try to combine things. And I already have the I have squareds, so I have a Pythagorean identity I can use. I have cotangent squared plus 1 equals cosecant squared, right? So let's write that down. If I can get back over here. I have cotangent squared plus cotangent squared theta plus 1 equals cosecant squared theta. That's my identity. So since this equals cosecant squared, I can substitute it in right here. So I'm going to have cotangent squared u minus, all right, if I'm going to substitute something in with more than one term, what do I have to do? Parentheses, okay? Or you go to math jail, right? It's right here. If you substitute more than one term and don't use parentheses, you're going to math jail. So in place of cosecant, I am putting parentheses cotangent squared u plus 1. Everybody okay with where everything came from? That means I get cotangent squared u minus cotangent squared u minus 1. These two are going to zero out, so I just end up with negative 1. Okay. What questions do you have? All right. So now I have sine of x times the tangent of x plus cotangent of x over cosine x. So I could distribute the sine of x in there, but I don't immediately see anything that would just like glaringly help me. But what is sine over cosine? Tangent. So you see how this right here is sine over cosine? Right? And so I could rewrite it as sine x over cosine x times tangent x plus cotangent x. Isn't that the same thing? Okay. So instead of sine x over cosine x, I can make that tangent x times tangent x plus cotangent x. And now if I distribute, I feel like maybe it'll make a little bit more sense. Okay? So tangent x times tangent x is tangent squared x. Now I'm going to multiply tangent x times cotangent x. How are tangent and cotangent related? Reciprocals. How is 3 and 1/3, how are they related? Reciprocals. And if I multiply 3 times 1/3, what am I going to get? 1. Because every time you multiply something by its reciprocal, you get 1. Okay? A monkey times 1 over a monkey is 1. It doesn't matter what it is, right? So if these are reciprocals of each other, when I multiply tangent times cotangent, that's just going to give me 1. If I multiply secant by cosine, I'm going to get 1. If I multiply cosecant times sine, I'm going to get 1. Does that make sense? So you don't have to, I mean, I could make cotangent into 1 over tangent and do all that, but they're just reciprocal, so it's just going to make 1. Okay? So now I have tangent squared plus 1. Do I have anything that would fit into? Yes, look, tangent squared plus 1 equals secant squared. So that means that I just come back over here and say, all right, that equals secant squared, and I'm done. What questions do you have? Anything? All right. So on number 5, I have a fraction and something that's not a fraction. I would like to combine it into one thing, especially because there's no, nothing glaring anything else. So that's usually what you want to do is just combine your fractions here. So that means this is over 1. So my common denominator is just going to be cosecant theta. So in order to get a common denominator, I'm going to have to multiply this first fraction by cosecant over cosecant, which will give me cosecant squared theta. Minus, and then I don't have to multiply this one by anything, then I got cotangent squared theta there. So remember that cotangent squared theta plus 1 equals cosecant squared theta, right? So once again, we can substitute. For cosecant, right here, I can substitute in cotangent squared plus 1. So I'm going to get cotangent squared plus 1 minus cotangent squared, oh, I forgot my theta. Sorry, don't forget your theta. Theta over cosecant theta. Okay. So here I put my parentheses because I substituted something with more than one term, but they don't really do anything here but group it, right? Nothing exciting is happening. So when I do cotangent squared theta minus cotangent squared theta, those two zero out. So I'm just left with a 1 in the numerator, 1 over cosecant theta, and what does that give me? Sine theta. Okay. Any questions at this point? The number 6 is one where we're going to split the fraction. So here's what I want you to think about as far as fractions go. If I have x over 2 plus y over 2, that equals x plus y over 2. We agree with that? It's pretty straightforward and basic. So if this is true, then going this way is true. If I am given this fraction, I can rewrite it as x over 2 plus y over 2, right? That's what I mean by splitting the fraction. You can't split the denominator, but you can split the numerator. So that means here, this will give me cosecant beta over cosecant beta minus sine beta over cosecant beta. Everybody with me so far? Just split them apart. All right, so then what's cosecant over cosecant? 1. So this is going to be 1 minus. Now, sine and cosecant are reciprocals, but this isn't going to cancel out because they're not being multiplied. All right, but I do know that this would be sine beta over, and then cosecant is 1 over sine beta. Right? So when I rewrite this is again 1 minus. So now I'm dividing by a fraction, so I keep change flip, right? So this will be sine beta times sine beta over 1. So that just gives me 1 minus sine squared beta. And what is 1 minus sine squared? Cosine squared. What questions do you have? All good so far? Yes? Alrighty. Let's look at number 7. So number 7, I have 2 fractions. I would like to put them together into 1 fraction. And the easiest way to get a common denominator is just to multiply the 2 denominators together. So my denominator is going to be sine u times cosine u. Which means I take that first fraction here, and it has to be multiplied by cosine over cosine. So this will give me secant u times cosine u minus, and then the second fraction has to be multiplied by sine over sine. So that will give me sine squared u there. Okay. Everybody good so far? Can I cancel these cosines out right here? No. Okay, but what is secant times cosine? How are they related to each other? They're reciprocal. So secant times cosine gives you what? 1. So this gives me 1 minus sine squared in the numerator over sine u cosine u. What is 1 minus sine squared? Cosine squared. So now I have cosine squared u over sine u cosine u. Can I reduce this? Yes, I can. I can cancel this cosine with one of those. So that leaves me with cosine u over sine u. And what is cosine over sine? Cotangent. Questions? All right. So when I look at number 8, you might be tempted to split the fraction, but you can't split the denominator. So there's no splitting there. And there's no Pythagorean anything. I feel like I'm going to have to do quotients and reciprocals, which means I'm most likely going to have to handle the numerator and the denominator. But I don't want to do them at the same time because that's a lot of rewriting that's not necessary. And I really would like for my denominator to be 1 term. So I'm going to work on that first, and we'll just keep rewriting the numerator. So this gives me tangent of alpha over, and then we're going to take care of this. So secant I know is 1 over cosine minus cosine. Okay? So I'm combining 2 things. I need to get a common denominator. So I need a common denominator in my denominator. My numerator is still tangent of alpha. The common denominator in the denominator is going to be cosine alpha, which means this one is fine, so it's just a 1 minus. This has to be multiplied by cosine over cosine, so that's going to give me cosine squared alpha. Okay, everybody okay with where everything came from? All right, so I'm going to just rewrite my numerator again, tangent of alpha over, so what's 1 minus cosine squared? Sine squared. So this is going to give me sine squared alpha over cosine alpha in my denominator. Everybody okay so far? All right, so now I've combined my denominator into 1 term, and it has sines and cosines, so I think I'd like for my tangent to be in sines and cosines now. So my numerator that's tangent of alpha is going to become sine alpha over cosine alpha. The denominator is going to be sine squared alpha over cosine alpha. I'm dividing by a fraction. I know how to do that. That's going to become sine of alpha over cosine alpha times cosine alpha over sine squared alpha. Now can I reduce some stuff legally? Yes. I can cancel these cosines. I can cancel this sign with one of those. So that leaves me with 1 over sine alpha. And what is 1 over sine? Cosecant. Cosecant alpha. Okay. Any questions? Okie dokie. Let's look at number 9. So on number 9, I've got cosecant x plus 1 times cosecant x minus 1. In the denominator, I have a cosecant squared, so I could use a Pythagorean identity, but if I did that, I'd be introducing 2 terms into the denominator, and your fractions are a lot harder to deal with when you have more than 1 term in the denominator. So I think I'd like to just leave that. The numerator looks like it's factored. Would those be easy to multiply back together? Because what is it? It's a difference of squares. So that means this is cosecant squared x minus 1 over cosecant squared x. Can I cancel out my cosecant squareds? No. That will send you to math prison, not even jail. All right, so, but that cosecant squared minus 1, remember I have the, I have cotangent squared theta plus 1 equals cosecant squared theta, right? So what is cosecant squared minus 1? Cotangent, right? Over. I just realized on my paper I did this differently. We're probably gonna go back and we're gonna like work it a different way too, just so you can see that there's different ways to work it. So cotangent is what if I change it to reciprocal? Cosine squared x over sine squared x, right? And then cosecant is 1 over sine squared x. So if I multiply, that's going to give me cosine squared x over sine squared x times sine squared x over 1. Then those cancel out, and your answer is just cosine squared x. So I'm going to show you a different way to work it, just because, so you can see that there's different things to do here. If I go from here, instead of changing it to cotangent, which is, there's absolutely nothing wrong with it, it's whatever makes the most sense to you, I could split my fractions here. So I get cosecant squared x over cosecant squared x minus 1 over cosecant squared x. Everybody okay with what I did and why I did it? Okay, so this first one is going to become 1, and this is 1 minus sine squared x. And then what's 1 minus sine squared x? Cosine squared x. You get the exact same answer. So you can say, oh, what you did in green was easier and shorter. Yeah, but if that's not where your brain goes, that's not what you're going to do, and that's okay. Instead, and I've worked it this way clearly before. That's what I did last period, and I don't know, I just started going down this road here because it was a Pythagorean identity. It doesn't matter. It's the same thing. They're both legal. It's both fine. Okay? We good? All right. All right, so number 10. We've got tangent theta plus cosine over 1 plus sine. So I think I would like to get a common denominator, but I think I would like to go ahead and make that tangent into sine and cosine first. Maybe things will kind of work out a little bit nicer. So instead of tangent, we're going to make this sine theta over cosine theta equals cosine theta, not equals, oh my goodness, plus cosine theta over 1 plus sine theta. Okay. So now to combine fractions, you have to get a common denominator. The easiest way to figure out what your common denominator is just to multiply the two denominators together. So we get cosine theta plus 1 plus sine theta. Come in. Oh, 1 plus sine theta, right? So that's going to be my common denominator, which means this first fraction has to be multiplied by 1 plus sine over 1 plus sine. So this will be sine theta times 1 plus, thank you, sweetheart, sine theta, plus, then this one has to be multiplied by cosine over cosine, so this will be cosine squared theta. Okay. Any questions about where anything came from? All right, so in the denominator, I'm not sure that I want to distribute because I don't know if that would help me, but in the numerator, I feel like I have to distribute or I can't combine or get anywhere. So we're going to leave the denominator alone right now and just rewrite it as cosine theta times 1 plus sine theta. Then up here, this is going to give me sine theta plus sine squared theta plus cosine squared theta. All right, so do you see anything that you could substitute at this point? What is sine squared plus cosine squared? 1. So where that sine squared plus cosine squared is, I just replace it with a 1. So now this is going to give me sine theta plus 1 over cosine theta times 1 plus sine theta. Now I'm kind of glad I didn't distribute, because if I had distributed, I'd have to factor it right back out. And you don't always know that, so sometimes you might get to a point where you go, you know what, I think it's time to distribute and see what happens. But here, this works out kind of nicely, right? Do I have something I can cancel? Yep, I can cancel that sine plus 1 with the 1 plus sine, because it's the same thing. I get 1 over cosine, and what's 1 over cosine? Secant. All right. What questions do you have? Okay, we're going to stop here for today. We're going to do the next 2 tomorrow and then a couple of more using some other identities on here. Your assignment is one that it's a worksheet / formative, which means you're going to do your work on here and then turn this into me, and then your answers you're going to put in formative. Now, here's the catch. In formative, on that little calculator you have, the only Greek letter that's on there is theta. So if this is A or X or whatever, you use what's on your normal keyboard. But if it's an alpha or a beta or a theta, you're going to have to use theta for all of them. Does that make sense? I didn't catch that until I'd already printed these, and I wasn't going to reprint them just for that. So you just, and that, it says on there in the instructions, don't be searching for alpha. Don't copy and paste alpha from the internet. It doesn't like that anyway when you do those things. So just use theta if it's a Greek letter. Okay. So I'm going to go ahead and give you this because you can get started on this even without us finishing, but we'll start here tomorrow.